Good morning, children. So last class we have discussed what are the factors are affecting the solubility. There are three factors are affecting the solubility. One is nature of the solute and solvent. Second one, effect of temperature. Third one, effect of temperature. Third one, effect of pressure. Okay, so these are all the three factors are affecting the solubility. Okay, solubility. Already we know what is meant by solution. So solution is made up of what? Solute plus solvent present in particular ratio. So that is called a solution. So solution is an example of homogeneous mixture. So already we have learned what is meant by homogeneous mixture and what is meant by heterogeneous mixture. Okay. So today we are going to start the new topic, concentration of a solution. So what is meant by concentration? What is meant by concentration? So how much amount of the solute present in the how much amount of the solution or solvent? So that is the definition for concentration of a solution. So what is the definition for concentration of a solution? So concentration of a solutions may be defined as amount of the solute is present given amount of the solution or solvent. So this is the definition for concentration of the solutions. So why we want to study the concentration of the solutions? So if you are preparing the any solutions, so based on the concentration, reaction also it will be differ. So if you are buying the paracetamol tablets, okay, so doctors they are recommending 50 mg, 100 mg, 250 mg, 500 mg, 650 mg. So that mg represents what ma? Concentration. Okay, concentration. So based on this, okay, the percentage of concentration can be classified into two types. Okay, so one is mass percentage. Another one is volume percentage. So what is meant by mass percentage? So how to define the definition for percentage? So percentage means what ma? 100 into 100. So mass percentage is defined as percentage. Okay, mass percentage is defined as percentage by mass of the solute present in the mass of the solution. Okay, that is the definition for mass percentage. So what is the formula? Mass percentage is equal to mass of the solute divided by mass of the solution into 100. Okay, so again we have to change this one. Okay, one more formula also we will frame based on what mass percentage formula. So mass percentage is equal to mass of the solute divided by mass of the solute plus mass of the solvent into 100. Okay, the solutions we have divided into mass of the solute and mass of the solvent. So mass percentage, okay, independent of temperature. So in what way we have to express the mass percentage? Weight bar weight. Okay, it is the unit which is used to express the mass percentage. For example, 5% of the sugar solution. 5% of sugar solution. 5% of sugar solution. So what is the meaning about 5% of sugar solution? 5 gram of sugar dissolved in, okay, 5 gram of sugar dissolved in 95 gram of water. Okay, hence it made up of 100 gram of solution. 100 gram of solution. So 5% of sugar solution means 5 gram of sugar in 95 gram of water. Okay, that is the meaning about what 5% of sugar solutions. Okay, next one, volume percentage. Second one what volume percentage. Second one, volume percentage. Okay, just you are changing instead of m, what will come? Volume. Okay, here also, so instead of mass, we have to write what we want to write, volume. Okay, so volume percentage is defined as percentage by volume of the solute present in where? Volume of the solution. Okay, that is the definition for volume percentage. So volume percentage is equal to volume of the solute divided by volume of the solution into 100. Okay, so here volume percentage is equal to volume percentage is equal to volume percentage is equal to here volume of the solute volume, here also volume of the solute divided by volume of the solute plus volume of the solvent into 100. Okay, so the volume percentage expressed in the form of what? B divided by V. V divided by V. Okay, so usually the volume percentage is expressed in what way? Volume per volume. For example, 10% by volume of any solution to express 10 ml of the solute present in 90 ml of the solvent. 90 ml of the solvent to make it as 100 ml of the solution. To make it as what? 100 ml of the solutions. Okay, next point. Okay, it is used when both the solute and solvent are liquids. Okay, both the solute and solvent are liquids. Okay, so volume percentage decreases when increase in temperature. Increase in temperature because of expansion of liquids. Expansion of liquids. Okay, so in day-to-day life, we are using different types of ointments, soap, or different things, okay, to express in what way ma? Either W bar W or V bar V. W bar W means what ma? Weight bar weight. V bar V means volume per volume. Okay, so next topic, hydrated salt or water of crystallization. Next topic, hydrated salt and water of crystallization. So some of the textbook instead of S, Z also it is given, it's also correct. So what is mean by salt? What is mean by salt? Okay, acid plus base to give what? Salt plus water. Already we have learned in this equation in lower section. By the neutralization of acid by base to give one new product that is called salt. Okay, when the salt is dissolved in water, okay, the ions are attracted by what? Water molecules. So if you are taking one example, copper sulfate pentahydrate. So what is the color of copper sulfate pentahydrate ma? Blue color. Okay, blue color. Okay, BLUE. What is the spelling for blue? BLUE. Copper sulfate pentahydrate. Okay, it is an example of hydrated salt. So what is the meaning about hydrated salt? Any substance or any crystalline substance or any compounds contains water molecules. Okay, that type of substance are the examples of hydrated salt. So what is the meaning about water of crystallization? So any substance contains water molecules. Okay, how many water molecules are present in a particular compound or substance? That is called water of crystallization. For this example, okay, copper sulfate pentahydrate. Penta means 5. Okay, so this compound or substance contain how many water of crystallization? 5. Okay, so another one example, magnesium sulfate heptahydrate. Okay, here how many water of crystallization? 7. Why? Because of how many water molecules are present? 7 water molecules are present. Okay, so we will explain. Okay, one of the equation for this concept. Okay, so we will take the copper sulfate pentahydrate. Copper sulfate pentahydrate. What is the color of copper sulfate pentahydrate? Blue color. Okay, copper sulfate pentahydrate. What is the color? Blue color. What is the spelling? BLUE. BLUE. So we may apply the heat. We may apply the heat. Okay, or in this way also arrow mark it is given. Okay, completely. Okay, off means what ma? Partial. Okay, completely. Okay, so here we have to apply the heat. Here cooling. What will happen? Copper sulfate plus 5 water molecules. Okay, so we may take the copper sulfate pentahydrate. We have to apply the heat gently. What will happen? It will lose as 5 water molecules become anhydrous copper sulfate. Anhydrous copper sulfate. Okay, this is the colorless one. Colorless one. Okay, again we may apply the cooling. It becomes what? Copper sulfate pentahydrate. Copper sulfate pentahydrate. The same way, one more example also it is given in our textbook. Magnesium sulfate heptahydrate. So what is the feeling? What is the chemical formula for magnesium sulfate heptahydrate? Okay, MgSO4 7H2O. MgSO4 7H2O. Okay, what is the common name of magnesium sulfate? Epsom salt. Epsom salt. The same way, okay, in our textbook, some of the hydrated salt common name, chemical formula, and IUPAC name also it is given in our textbook. Okay, just to have to go through that one. Okay, blue vitriol, Epsom salt, gypsum, green vitriol, white vitriol. Okay, next one, hygroscopic and deliquescence. This is the last topic of in this lesson. Last topic of in this lesson. Okay, hygroscopic and deliquescence. HYGROSCOPY, hygroscopy. Another one, deliquescence. Another one what ma? Deliquescence. Last topic of in this lesson. So what is mean by hygroscopy? Okay, certain substances exposed at ordinary temperature. Okay, certain substances exposed the atmosphere at ordinary temperature. So we may take any one of the substance. We have to keep in the atmosphere in what condition? Ordinary temperature. Ordinary temperature. We have to keep in the ordinary temperature. What will happen? Absorb the moisture, absorb the water molecules, without changing their physical state. Without changing their physical state. Okay, such substances are called hygroscopic substance. That entire property is called hygroscopy. Okay, so what is the definition for hygroscopic? We may take the substance, we have to keep in atmosphere at what condition? Ordinary condition, ordinary temperature. It will absorb the water molecules. Without changing their physical state. Okay, suppose you may take the substance, it may be in the solid condition, it may absorb the water molecule also, it will not change their physical state. Physical state means what? Solid state. It will not convert it into liquid state or gaseous state. That type of substances are called hygroscopic substance. That properties is called what ma? Hygroscopy. Example, concentrated sulfuric acid. Okay, one of the best example. Second one, phosphorus pentoxide. P2 O5, phosphorus pentoxide. Third one, quicklime, calcium oxide. Third one, calcium oxide. Okay. Fourth one, silica gel. Silica gel. Okay, SiO2. SiO2. Okay, these are all the examples of hygroscopic substances. Okay, next one, deliquescence. Okay, the same definitions. Okay, so we may take the substance. Okay, we have to keep in the ordinary temperature. It will absorb the water molecules. Okay, it will change their physical state. It will change their physical state. That means what is the meaning? It may convert it into liquid form or gaseous form. Okay, that type of substances are called deliquescent substance. That properties is called deliquescence. Okay, for example, sodium hydroxide and potassium hydroxide. Sodium hydroxide and potassium hydroxide. Okay, caustic soda and caustic potash. Caustic soda and caustic potash. One more example also it is given, ferric chloride. Okay, FeCl3. Okay, so these are all the solid substance. We may keep in the ordinary temperature. Okay, in the atmosphere, ordinary atmosphere, it will absorb the water molecules. It may convert it into liquid form. So these substances are the examples of deliquescent substance. That entire properties is called deliquescence. So what is the conditions for this one? Okay, the temperature is low. The atmosphere is what ma? Humid. That means what ma? Water content. Okay, high level water content. Okay, next one. So what is the difference between hygroscopic substances and deliquescent substances? Okay, first point you have to write the definition. Okay, second point, okay, here physical state it will not change. Here physical state it will change. First point, definition for hygroscopic. Here you have to write the deliquescence definition. Second point, here physical state it will not change. Here physical state it will change. Third point, you have to write the examples. Here 4 examples are given. Here 3 examples are given. Fourth point, okay, in our textbook only 3 points is given. One more point also you have to add. Okay, that fourth point. Okay, hygroscopic substances may be amorphous, solid or liquids. Solids or liquids. Okay, but deliquescent substance maximum are crystalline solids. Maximum are what ma? Crystalline solids. Okay, these 4 points. Okay, you have to make it as a tabular column format. You have to write. Okay, that is called what ma? Difference between hygroscopic substances and deliquescent substance. Okay, today homework. Okay, you have to read that entire lessons. Okay, entire lessons. Revise lesson 3. Okay, you have to read the whole textbook. Okay, tomorrow evening, okay, 1 mark test. Okay, usually we will conduct through Nitra app. Okay, that 10 1 mark questions based on this entire lessons. Okay, so next class we will start the evaluation part. Okay, the problems one by one I will teach. Okay, so thank you children. Thank you.